Yeah, because Scrooge converts to being a good man. All Christian at that time, just didn't believe it, and then he got visitations. Then he changed. You not watch that show? You haven't watched A Christmas Carol? Like mandatory.
You have to watch it now.
Oh, you gotta watch it. It's the best. It's one of the best Christmas shows in the U.S.
I just remember watching Captain.
Okay, I got the wrong link.
The Wi-Fi is not working. Am I lying?
Okay, Nick, you're already in the Christmas spirit? You're already in the Christmas spirit? He's got a... Okay, whatever. I'm not going to make fun of it. That's good for him. Hey, you don't need to see me. Screen share. What's up? Look at all these cool grids. I wonder if I should do this one instead. What do you think? No, that doesn't work, eh? No? Is that a good template? No? That might work for notes. Let me think if I care. See, Scrooge, right? That's me, man. Conservation of momentum. So I'm going to go over what you covered last videos that we watched, a bit of it on impulse. So we can redefine the net force. Instead of MA, we can redefine it as a change in momentum. Okay, and then we rearrange this, we cross multiply, we rearrange it to get that. And we give this a name. This is called call that impulse. And they're equal. The impulse is equal to the right-hand side. The right-hand side, we tend to refer to it as change in momentum. This is what you're given. Okay. I mean, we can add that to the formula sheet. It's just a simple rearrangement. But this is the, well, practical form of it. We could change this into triangles final minus initial. And then we go this, like this. Okay, so that's the more practical form. You can simplify it even further if you want, but that essentially is it. I'll go one more step. This is a little easier to work with, but don't forget your little half arrows, reminding you that there's direction here. North, south, east, west. And mathematically, that means positive, negative. Okay, so either one, either this or the one above it. That's a more practical form. Of what? Finding impulse. Which side of the equation? I keep wanting to sit. I realize that's what's causing my back problems. Okay. Which side do you use? It depends upon what you're given. If you're given force, then you'll be given time with it. So use the left-hand side to calculate impulse. If you're given velocity, you'll be given both final and initial. Use the right-hand side. Yes, to calculate impulse. Okay, so the question, what's the impulse? Again, use whatever side is practical given the information. Given velocity, use the right side. Okay. It could be a question of, instead of finding impulse, find the change in momentum. So if you see that phrase, usually it's the right side that you're going to use. But you could alternate. If you're given the force, use the left side. They're equal. Impulse and change of momentum. Okay, remember if there's any mention of east, east implies it's a positive value, positive velocity. And west implies you have to insert a negative in front of the number. And then similarly with north-south. So just keep that in mind when you're reading the problem to insert the proper sign. Okay, so now this ties into what I first stated above here, conservation. We're going to use this equation here. I'm going to look at this scenario. So this is going to be before I think here before, and then it hits, and then there's a change in momentum. It's a simple scenario where you have one ball, ball one, heading this way. This is before the collision. It's got a mass m1. It's got a velocity v1. Same thing on the right, ball two. They're going to hit. Obviously going to hit. Okay. During the collision. trying to stand up when I do this. Because it was this, when I was leaning down, that was preventing my injury from healing. I've been doing it for like 2 days now, and I can already tell the difference. So. Anyways, they're going to hit. You draw the two balls together. Touching. Okay. Don't tell me, but write in the forces. What do you think the forces are acting on ball 1 and ball 2? How do you think they compare to each other in length in terms of arrows? Just draw it in. In which direction? Okay, so this is the force on ball 1. Subscript, the first subscript refers to the object that's being touched. In this case, ball 1. The second number refers to what's causing the force, ball 2. So this F12 means the force on 1. 2 to 2. Notice how I draw F2. Should be close, it's a little bit off. One, two. Oh, that works. This grid system actually helps a little. Okay, so this is the force on 2. 2 to 1. And they touch. They touch for an equal amount of time. Right? They're in contact for the same amount of time. We'll call it triangle T. Could be like a microsecond. When they move off, so this is after collision. Again, ball 1's now it's moving this way. I'm going to put a red arrow just to indicate it's a velocity. I'm not talking about force now. It moves off with a new velocity. So we can't call it V1 because that was the previous velocity. So we use a prime. Prime means after collision. You're going to see that a lot now after collision. And then similarly with ball 2, it heads off to the right. We can't call it or label it V2. That's what we labeled this previous velocity at the beginning. Call it V2. So we have to differentiate it. It's after the collision. Okay. So go back to this middle scenario when they hit. I just said something important here. I said that the forces are opposite, you can see obviously in direction. And I mentioned, if I didn't mention it, I'll mention it now. They're opposite and equal. Oh. Now I'm going to write them as vectors. So what I just said in words, you can represent in terms of, doesn't matter where you put the negative, right side, left side. That means they're opposite and equal forces. Write that down here. Leave a little space now to the right of F12. Okay, I'm going to just do a little mathematical trick. Multiply both sides by what is this triangle T? It's the time that they're in contact for. They hit each other. That's what an impulse is. Impulse is when you have a strong force and they hit each other for a short time. Boom, boom. So they deliver an impulse to each other. Now, we know these two times are equal, right? That's equal. It's the same variable. It so happens that I can label this time 1 and time 2. That's important for what's coming next. What does that represent? It just refers to the time that each of them is touched for or feels an impulse for. And it's equal. This is equal to that. So, okay, so what is this? How can we express this in terms of velocity? That's what I'm after. Well, we can rewrite the above equation as on what ball? On 1. Ball 1. I can drop the 2. Won't have to worry about that. And then the above right-hand equation, same thing. Just change the momentum on 2. That is the conservation of momentum. That's it. In shorthand notation. Let's see how. Let's actually show you the form that you're used to. This, what is triangle P? Triangle P is just final minus initial of 1. What's the right side equal to? Same thing. Of 2. Okay. Now you do it. You group the like terms together. Group all the ones together. Not the ones, pardon me. Group all the initials together. Put them on the right side. Eventually get to the right side. Start by just grouping all the initials together and group all the finals together and put them on the other side. Separate the initial and the final. That's what we're after. Okay. Now if you start with the right side, so. Negative times a negative is positive. So I'm putting the initial on the right side. I mean, I can switch sides later on. Remember, this is negative here, so I'm going to add it to both sides. It should be a mistake here. It's confusing. Okay. Now, that's more like what you're used to. We're going to put this on the left side and this on the right. Just switch places. And don't forget the vector notation because that comes in handy. Remember, you can deal with an east or a west, and the west always has to be included as negative. Okay, so we're going to simplify. This is the conservation, close to what you're used to. We're going to drop. I'm going to erase the initial. You know what? If you look back, that's going to confuse you. So I'm just going to rewrite it. I'm going to drop the. I'm going to put the 1 first. Just switch places between that and that. And drop the initial. Is equal to. And I'm going to drop the final. And in place of the final, I'm going to put my little dash. Means final. Yeah. Yeah. That's what you're used to. That's what you're given on a formula sheet. That's it. Now, one last step here. Let's write it in the more practical form. This is what you need to convert to. Okay. Now, what do I need to add here on the right side? The prime, the little dash. It's called a prime. Okay. You can add it here to the m if you want as well. You don't have to, but usually mass is constant, so you can add it if you want. But in our cases, mass will be constant. Don't forget your little vector notation. Include a negative if it is. So the problem is this. You're given this in a formula sheet. You need to get to that. So practice writing the more practical form. This is the practical form. That's the one you're going to use to do calculations with. Okay? Good news. We're now using this text. So page 217. Yeah. Yeah. Take a minute break. You can.
Which one is it? Is it the white one?
It's the small one. Yeah, guys, listen, that's the one where you don't need the thick one, okay? Bring the smaller, thinner one for now.
They're the same size.
Is it? Okay, well, it's the green
It's the
one.
white one. White and green one.
White, green one. Bring that from now on. Yes, sir. I turned to, we'll start in a couple of minutes. I'll give you a couple of minutes break. 217. What time is it? I got time.
Page 209. 217.
217. Start in a few minutes here. Okay, so this is from page 270. I'm just going to go over the examples. This is all review from grade 11. But where it gets tough, what's coming next, this is all what's called one-dimensional. This is one-dimensional. One-dimensional means just along the ground. Usually it's along the ground. So they hit, they collide, they stick, they bounce off each other, and they move in different directions, or maybe they stick and they move in the same direction, or they stick and they come to a stop. Okay, different scenarios. Or you can have an explosion problem where you have like a gun firing off and it fires a bullet, and the gun moves in the opposite direction. So this is all a one-dimensional case. Using this equation here, either one, this one or this one, can be used in all dimensions, not just one. If it's one-dimensional, then we're talking about east-west, where, keep in mind, west is negative. So we're going to make a list. I want you to make a list like I'm doing. So start with M1. Don't tell me, but write it down. And we're going to use slightly different notation. If it's a final velocity, they use F. I'm going to keep it simple. Just use the prime. Use the prime to mean after the collision. And remember to write your velocities with that little half arrow. Okay, so you're paying attention to east-west. East is positive. After is a little dash. Proper word is prime. That means after the collision. They're going to use final, but it doesn't really physically make sense. Makes more sense to talk about after, and that's what the prime represents, after they hit or explode. So what's V2 prime? That's your question. So make a list. I'm going to save a little time here because it's short in blocks. I'm going to go back to this. This is the equation you're going to use. This is it. Oh. Crapola. Okay. They hit. Whenever you have any sort of collision, it's a conservation problem. That's your clue. Bodies hit, they bounce off, or they stick, or there's an explosion. Use this. Okay. Okay, so just fill in all your values. You got. Don't forget your negatives. I need more space. That's your unknown. Yeah, I gotta talk to you outside. Outside, please. No. I didn't come on time. That's your job. Okay, you'll come on time. And then I come after school, I can go over tutorials with the other guys. You gotta be ready for it because I don't think you can I'll go read some of the things to remind you to start anyway. You need a full hour, so stay at least an hour. Okay, so you can do the math. This should be okay for you. Don't forget your prime. Yeah. And your units. Okay, we'll go down to middle of page 219. Read it over and correct the diagram. Before we move on here, there's a little bit of a confusion. What's the velocity of the lock cars as they move together? One sec here. So one is supposed to be, I don't know what their consider direction is positive before. It's a confusing diagram because one is moving towards the east. And then hits two. Two is traveling this way. That's what they should have drawn. Anyways, just read the problem. We'll make a list. $1,100 is the mass of one. And we're told you can keep it. Here's the beauty about conservation. Whenever you have a collision, use the conservation law. You can keep the velocities in kilometers per hour. So one exception. Otherwise, you have to convert to meters per second. But as long as they're both kilometers per hour, as long as all velocities are the same unit, you're fine. So it's traveling east. And it collides with M2. Guys are lucky, man. You got it? I don't know what to say. Okay, 1.3, traveling. Again, pay attention to the words west. It's going to be negative. And yes, you can stick with kilometers per hour. They stick together, so they move off. Here's the trick. Prime means after. If it's a common velocity, you don't need a subscript. You put 1 plus 2 if you want, but you don't need it. Just put the prime there. They stick together. That's the question mark. Okay? Okay, Mr. C is going to cheat again. This is your equation. Okay? You need to be able to get from the equation that you're given in the formula sheet to this. And then let's look at this. After the collision, let's fix this up so it's simplified. Okay? After the collision, you have this. They move with a common velocity. Drop the subscript. Don't need it. They move together. With a common v prime. And we can factor that v prime out. It's common to both terms. You complete it. I'll just write in the left side. You complete what I was going to put. What did I factor out? That variable goes outside the brackets. Yeah, v prime. Good. That's what we can simplify to. Then it's a little easier to deal with. Then just go through your list. This is your M1. This is your V1. This is your M2. This is your V2. Make sure it's negative. And this becomes your unknown. Let's plug in. I'll start over here. Don't forget the negative. Right? Because it's moving towards the west. Stupid thing. Is equal to what? Is equal to this side here. Oops. Crap. Need the room. So on the right side, you get I don't have enough room here. Okay, try another trick. Kind of like this. Okay, on the right side, you get in brackets and the unknown outside the brackets, which you want to solve for. So this works out to be this. And this added together works out to be 2.4. I'll put it in brackets just to show you it's the same thing. And then just divide the 8,000. By the 2.4. It's positive. You get a positive answer, so it's east. And it's the same unit you started with, kilometers per hour. Okay? Last problem. Read page 220, where it says explosion. For you gun enthusiasts. My cousin's got lots of guns in the States. He's got a hole. You walk in, he's got a hole. What's it called? They're all locked up in this huge vault. Huge vault. And one of the reasons why he's such a big enthusiast is because Utah is actually the birthplace of North American guns. Yeah. Yeah, I forgot the name of the guy. It'll come to me, but Colt? Colt?
Oh, that sounds about right.
I think. No, it's. Give me a second. Utah guns. I went to the museum. It's fascinating.
Have you shot a gun?
Yeah, I have. Actually, I'm pretty good. I don't know why. I just everyone says, "Oh, what the heck? How many times have you?" And I said, "I don't know. I've never tried it before. It just comes naturally." So apparently, I'm good at it because, but I had to. They shoot these things out, and then yeah, that's what it is. Browning. You ever heard of the Browning?
Yeah.
Yeah, that comes from Utah, Ogden, just north of Salt Lake. It's an awesome museum. Yeah. Yeah, he was one of the actually he was the best gun designer, period. And the guy who was commenting, the curator was saying no one could figure out how he did it. Yeah. But it all came out of that town just north of Salt Lake in Ogden. So let me just take a look. Yeah, it's right next to the Union Railroad station. I remember that. I'm looking at it now. I think it's north. It's north of the city, right? Yeah, it's north of the city, parallel to the lake. So it was the Browning that helped win World War II. Yeah, they were incredible, fine-tuned pieces of machinery. Yeah. Okay, so if we read this, let's make another list. First of all, what should stand as what I highlighted here: explosion. So you can use the conservation law, collision or explosion, because they both involve opposite and equal forces. For every action, there's an opposite and equal reaction. Which law is that? Yeah, good. I'm going to call the bullet object 1. Okay. What is V1? 0 to begin with. They're not moving. Hasn't been fired. Okay, we don't know the velocity of 2. Prime, a little dash means after it's fired. It's going to be negative because it's going to be in the opposite direction. The gun, what's called recoils. When it kicks back, we call it a recoil. Okay, so this is Mr. Cohen is going to cheat again. Saving time. Lazy. Okay, there you go. Use that. Why? It's an explosion. That's your clue. Collision or explosion. Use that. Simplify it. This is 0. So is this. The gun and the bullet aren't moving. 0 times anything is 0. Well, it says it moves after, right? You know from experience, it's fired. Before it's fired, it's just sitting there. Not moving. So this velocity and this velocity are 0. 0 times anything is just 0. I'm going to put this over on the left side. I'm solving for this. I'm solving for the gun's recoil speed and direction. We know it's going to be negative. Okay, just plug in your values. That's why you make a list up. Okay, you expect it because this is a gun. This represents the velocity of the gun. You're expecting it to recoil at a slower speed, and it does.
Please excuse the interruption. When this class finishes, could the following 3 students please come to the office for a pickup before they head off to their next class? Gabriel Johnson, Vernon Espiritu, and Kate Devine. If you could come to the office when class ends and before the next one begins, and get your items. Gabriel Johnson, Vernon Espiritu, Kate Devine. Thank you.
So remember to check your answer if it makes physical sense. Should be less because it's a gun. It recoils at a lesser speed. Yeah. Okay, so for homework, you can start on it. We got 5 minutes. Go backtrack a little. I didn't give you homework last day, but page 212 in this book. Make sure you take into account east, west, north, south. The 213.
All the questions.
You don't need to do all of them. I'd say do 1 to 9. They're easier than you think. You can start on now. You'll whip through them. I didn't go through units for impulse because I went through it quickly, right? So go back over that. Units of impulse. Should have been mentioned in that video. Impulse units is Newton seconds. Okay, or kilograms meters per second, either one. That's the unit for impulse. Or change in momentum. Remember, they're the same thing. I just put change in P for short. I'm not finished with the homework because you should whip through that. I want you to get started on what we went over. So page 221 as well, 1 to 3. If you ever are concerned about, you should write it down. But if you missed writing it down, I post the notes later in the evening, right? So just go to the end of the notes. This is a whole new set of notes, so you don't have to scroll all the way to the bottom anymore. But they're there for you. That saves me time, right? Because I'm busy posting this, and I'm busy loading down the video to YouTube so we can get access to it. Then I'm posting the link to YouTube. It's all time consuming. So you do your part, just scroll to the end of the notes. That's where the questions will be. Yeah, that museum was cool.
Would you go back?
Pardon me?
Would you go back?
I go back every year. Yeah. But when I go back to the museum, yeah, I'm going to ask my cousin to take me there again. That was so fascinating. I've got an older cousin, and I got his son who's a younger cousin. We're both into it. So, yeah, it's great. Do you use the note?